Imagine a journey across the entire universe, tracing every element from the simplest hydrogen atom to the most complex, super-heavy creations. At the heart of each element lies the nucleus, built up from protons and neutrons, the building blocks that define what is possible in the periodic table. Our odyssey begins with a single proton, hydrogen, then two for helium, and onward the count grows, giving rise to carbon, iron, gold, uranium, and beyond. But as we continue adding protons, reaching higher and higher atomic numbers, we eventually confront a fascinating question. What happens when we reach the very last proton? Is there, in fact, such a limit? Protons carry a positive charge, and as they accumulate in a nucleus, their mutual repulsion grows. To counteract this, neutrons act as a kind of nuclear glue, stabilizing the nucleus through the strong nuclear force. Up to a certain point, this balance holds. However, as atomic number increases, the repulsive force overwhelms the binding force, making the nucleus more and more unstable. Scientists have already synthesized elements with well over 100 protons, super-heavy atoms like oganesson. Currently the heaviest known element with 118 protons. But these exotic nuclei are ephemeral, decaying in fractions of a second. Predictions suggest there may be an island of stability further along, with super-heavy elements that possess longer half-lives, perhaps persisting long enough to be recognized and even studied in detail. Yet, even the most optimistic models suggest a fundamental boundary exists. As we push toward the edge, we approach a theoretical end, a point where the strong force can no longer counteract the electrostatic repulsion of so many protons. Physicists estimate that this last proton, the highest possible atomic number for a nucleus, might be somewhere between 170 and 210 protons, though this is still deeply speculative. Beyond this, even if such a nucleus could be assembled, it would immediately fly apart, its existence limited to a fleeting moment. Thus, reaching the last proton is not about uncovering a new superelement for practical use. Instead, it marks the outer limits of nature's laws, a frontier where the very fabric of atomic matter gives way. Exploring where this boundary lies gives us insight into the forces that govern the universe and reminds us that, even at the subatomic level, there are ultimate frontiers waiting to be explored.